Okay. Hey, everybody. Welcome to 2020 PSBC. Let's see how many people are on right now. Oh, got people are on right now. Got 7 people right now. Sweet. Well, hello, everyone. This is going to be, I think, most of our first times ever doing a live stream. So just want to apologize ahead of time for any hiccups or, anything that might be happening on here that comes unexpected.
Yeah, we'll try our best.
Yeah. Hey, guys, and since this is YouTube, make sure you like and subscribe, and don't forget to follow.
Smash the like button.
Yeah, I gotta get that plug in there. Feel like a real YouTuber.
Let's give it 5 minutes, 2:05, and then we'll just let people trickle in, and we'll get started.
Great idea.
All right, sounds good.
How's everyone's midday been going so far?
It's a nice day outside.
It's been good so far.
Beautiful
Yeah,
weather.
I can usually tell how good of a day it's going to be by the mood and attitude that my dog's in. So whenever she gets like really hyper and excited, and she can tell that she's ready for a walk early in the day, then I know it's going to be nice. But if it's like gloomy outside, she'll just kind of like lay sideways on the couch.
Nice.
It's like all those memes that you see of oh, hey, you know what? Since we're here, is someone watching the YouTube for comments? So one of you guys want to bring up comments in case somebody's...
Yeah, I have it on my phone. So that's
a good idea.
I mentioned it for the viewers. If there's any comments or questions, feel free to keep them live, and we'll try to answer them live. If not, we'll get to them after the video. Or questions, feel free to keep them live, and we'll try to answer them.
Cool. Oh, within that time, we lost a couple viewers. We're at 4 now.
No,
Don't leave us, guys. Stay with us. Hold strong.
We'll come back at 2:05.
Right. They figured they had just enough time to go grab some coffee. I made sure I got my cup. I got my Orange County cup. So keeping it real, I don't know if you can see that. No, it's a little bright. It's okay. Take my word for it. So I'm thinking that this year, since it was all virtual, that you guys think that we'll have to go virtual next year?
Probably.
There's like a chance that we are.
So this is like a really good trial run for what's to come next year, and I think I feel really good about everything that we've put together, and think of all the content we'll have this year that we can combine with next year's content.
It might come down to we have to book our venue maybe 6 months ahead. So in 6 months from now, we don't know if locations are going to be allowing gatherings of our size. So that might set our virtual 2021, but still TBD, and we'll see how this pandemic kind of develops.
Yeah, and we're totally up for suggestions. So if any of you out there like have any other really good ideas or thoughts that you'd want to share with us on what we might be able to do to make it more of a social distance friendly popsicle bridge competition, let us know. I mean, I think we're all up for it.
Exactly.
Like, I don't know, like maybe one of your uncles owns the Rose Bowl, and you think we could host it in the middle of the Rose Bowl and social distance in there and still watch it. I don't know. So if one of your uncles or aunts do own the Rose Bowl, let us know.
Jared, do you know if you see this will be able to be re-uploaded after the live?
Yeah, that's a good question. I think once we're done with this stream, it'll be live for everybody to watch over and over and put on repeat and share with your friends. I mean, this is going to be a hit, and I'm excited for it. So it'll probably be how we all go viral. So figure it out now if you want people to know your real names, gents. I mean, this could be it.
All right, fellas. I think we got a comment from Michelle Morgan.
Okay, they're having a watch party on Zoom, so multiple viewers are signed on.
All right. Welcome, Bravo Medical Magnet. Great to have you. Stellar job on your reports and bridges, so this is exciting.
Oh, that was Michael Morgan, not Michelle.
Oh.
Thanks, Michael.
Oh, Michael. Yeah. Thanks, Michael.
Students were able to participate. You'll see that it was actually your 3 teams that stuck it out. So essentially, your students are competing for first, second, and third. So yeah, great job to your students, and you'll see how they performed here, and to all the students watching, good job. We really enjoyed it, and essentially you guys kept PSBC alive this year, so we're really happy that we were able to continue with it.
Yeah, great job. I mean, it's one of those things to where initially we had about 16, 17 schools signed up probably about 3 or 4 months in advance. And then once the whole pandemic hit around February, teams just kind of started dropping off, and we get it. It's there are a lot of challenges and hoops, and we just wanted to make sure that education was still available, for the students to jump in and compete and learn a little bit about engineering and bridges, and have a little bit of fun with it. And so we know that some teams weren't able to overcome those challenges, but you did a great job and stuck it out. So yeah, so all, the prizes and awards will be well deserved.
Exactly.
Okay, but I think we were at 2:06. Want to get the show on the road?
Yeah. So we'll introduce ourselves, and then just a brief summary of this first video. This first video is it's purely us going through the dimensions and checking the bridge parameters. So after this video, we'll move forward to the actual loading and the more exciting part. But as far as introductions, my name is Guillermo Medina, Memo for short. I am a civil engineer working in Orange County. I grew up in Compton High School, and I've been working with ASCE, K-12, and PSBC efforts for close to 2.5 years now. Whoever's next, go ahead.
Okay, I'll go next. Hi, everyone. My name is Raul Rodriguez. I'm also a civil engineer working here in Orange County. I'm local from Mission Viejo, and this is actually my first year. I graduated last year. So yeah, right about 1 year with AAC YMF.
Awesome. I'll go up next, Jared. Hello, everybody. My name is Victor Aguirre. I'm a civil engineering consultant at Hewitt Zollers out in Orange County. This is my 3rd year as a K-12 outreach co-chair and first time as a PSBC chair. Grew up in Long Beach, California, and looking forward for you guys to enjoy, what we have set for you guys.
All right. Hello, everybody. My name is Jared Lindo. I'm with OC YMF, ASCE, and Branch. And this is the first time that I've actually hosted the PSBC, so I'm really excited. We've got a great team here, as you can see. I work for Caltrans, civil engineer, and I'm originally from a very small town of Gustine, California. You might have to Google that one. There's more cows than people. So yeah, that's a little bit about myself. I think we're ready to go.
Yeah, and then just in case now that we're just while we have all of our people, for everybody, for the students watching, we will work with you later on to get you these awesome shirts that 3 of the 4 of us are wearing. I actually forgot mine, but you can see our Orange County PSBC shirts. We do have shirts for everybody, so we will work to get you those later on. And if anybody else that didn't participate is watching, we do have a little bit of a surplus of T-shirts. So if you're interested in getting a PSBC 2020 shirt, just hit us up. You can send us an email or even message here that you want a shirt, and we'll do our best to get you a T-shirt. They have our awesome sponsors on the back, and yeah, just wanted to make that note.
Thanks, Memo. All right. And as a little bit of history, this has been going on for a while, PSBC. So if this is your first time, we're glad to have you here. But if you're returning, then you know a little bit about how this goes. And it's essentially a competition for all Southern California schools to come together and compete against each other and just kind of educate themselves on engineering and their practices and just get a little bit of a real world taste on what it's like to work in teams together, coming up with a design, construction, and product. So we had some really good applicants and some really good participants. All the submitted bridges and reports, they were awesome. Essentially, everybody's having to create a bridge, a slideshow presentation, and a report and presentation. Did you guys want to comment on any of that? No thoughts? Okay. So let's go ahead and, as Memo said, we'll go through with the first video on how we had to go through looking and inspecting the bridges prior to us loading them. Because if they didn't meet a very specific criteria, then we either couldn't load them or they would be deducted possibly penalty points for not following the rules as they were written for the PSBC rulebook. So let's go ahead and go through that process.
Here we have bridge 201. First thing, we're going to identify that the bridge was made of white all-purpose glue.
So we're just reading out some of the criteria. Memo, you want to talk a little bit about what you're doing here?
Totally. Yeah, I mean, like Jared said, we're just checking that no crazy glue was used, that no Gorilla Glue was used.
And we're checking that there's Common Craft wooden sticks. All the bridge are standard Common Craft wooden sticks. Now we're going to check the 50% rule.
Verifying that no flat plane is overlapped another flat plane of a stick by more than 50%.
Bridge is in compliance. Now we're going to check that none of the popsicle sticks were altered or modified, with the exception of the roadway sticks. And this bridge has no altered sticks or modified sticks. Now we're going to check the bridge length.
$37 inches.
All right.
Got it.
Now we're checking bridge height.
Why don't you turn the stick towards the camera?
Can you guys read that? That is 9 inches.
9 inches.
9 inches. Now we're checking bridge width.
4 inches.
4 inches.
Next step, to check if the roadway is continuous, flat, and level.
And so the bridge that we're watching here, this is team prototype, right?
Next,
bridge number 1.
The bridge roadway width is 4 inches in clearance. Minimum 4 inches.
Yes.
What's the width?
Looks like everything's in compliance so far as the dimensions.
Okay. Now the bridge roadway minimum height clearance, minimum 4 inches. Bridge is obviously more than 4 inches. Okay. Now last step is to check the roadway clearance. Check that this opening is 1.5 inches by 1.5 inches.
Minimum. Yeah.
Minimum.
1.5 inches.
Oh, the middle piece. Like from this stick to this stick. 2 inches?
Yeah, 2 inches.
Okay.
Okay, and then wait.
Oh, now we're weighing the bridge.
Yeah.
Is it on?
It's very hard to tell.
Yeah, 0 up. Okay.
Okay, we're weighing the bridges. This will be part of our efficiency calc when we go to load the actual bridges.
This is bridge 202. First, we're going to check that the bridge is all white glue.
This is the next bridge that we're testing for compliance. Team number 2,
Bridge is in compliance with
which I believe is
glue.
the
Next
Chevron
is to check
team.
that the bridge is crafted from common wooden craft sticks. As we can see, the entire bridge is crafted from common wooden craft sticks. Next step is to check the bridge's 50% rule.
So now this is critical. This is our 50% rule.
So we have 1 inch of overlap, right? We have a 1/4 inch of overlap. We have a 1/4 inch of overlap. And we have 1 inch of overlap.
But these are on different phases, so they only count towards one side of the popsicle stick.
So these bridges are sharing 2 1/4 inch of face overlap, so therefore not violating the greater than 50% rule. Now we're shifting over to these. So there's 1 inch. There's a 1/4 inch. There's another 1/4 inch. There's an inch. So in the case of these, since it's on the same face, these bridges have a 2.5 inch of face overlap. Therefore, it is in violation of the 50% rule. So the bridge will be docked for that.
Okay.
Yeah,
So I just wanted to go ahead and just pause at that moment. So you could tell that this team took a lot of time to really ensure that they didn't violate that 50% overlap rule, which is basically, let's see if I can, I've got their bridge right here, is when you have a popsicle stick, one of the faces of each popsicle stick is about 4.5 inches long. And you can't have more than 2 1/4 of that popsicle stick covered basically by another popsicle stick. That's our 50% rule. So on the first part, the first gap where they've got those cross members on their truss, we explained that they measured it just enough so that they didn't violate that 50% rule. But then when you go to the next opening of their cross members on the truss, they have both cross members on the same horizontal face, which essentially gives you about, I think, 3/8 for each popsicle stick. And then at the ends, it's held together and held horizontal by another inch overlap on each side. So that actually puts them over the 50% rule. So it's like every other space on their truss system violates it. Sound about right, guys?
Yeah. And if Team 2 would like more clarification on it later, we could totally go more in depth. Jared, if it's easy enough to flip to my screen, I have a picture of it zoomed in.
Oh yeah, let me share that for you. Okay. We see your screen memo.
Okay, so what Jared's saying is right. These segments that repeat every other segment, these are fine, right? And one of the reasons you'll see in the loading, one of the reasons this bridge did so well is because it is so robust and so beefed up, right? It's an amazing thing what these students did. It is unfortunate about the 50% rule, right? But overall, we still did good. So in these pieces where this bridge, this popsicle, and this popsicle are touching at the X, they're sharing the different faces, right? It's on the inside of the stick and the outside of the stick. So that's fine, right? The issue is over here in this one. This, if you could see kind of this is the most I can zoom in.
Yeah, they're sandwiched in between, right?
Right. So each of these sticks is covered for more than 50% of it, right? Because the stick is 4.5 inches. We have an inch back here to connect to the next piece. We have an inch back here to connect to this piece. That's 2 inches already, right? And then it would have been fine if it was just one face of the 3/8 width. But since we have these two faces, that's what gets us over that 50% rule. It's with engineering, that's like you work really hard to push your design to the limit, right? And then that's why it's so important to have, like in the work we do, right? We want to make sure our designs are efficient, just like how this bridge, you'll see when we load it, it's extremely efficient. And then the part that happened here, it could have been a little bit of oversight. Maybe the rule was misunderstood a little bit. Maybe we could have done a better job of explaining it. But essentially, in our job, the way that relates is we have a QC process, right? Where we have quality control, quality assurance, where we have designers such as the four of us. We take our designs to the project manager, to the project engineer, to the higher ups to make sure that what we designed and try to be efficient is actually still valid and is still correct and is still make sure that it's safe for people to use, right? So that's kind of, I hope it's, at the end of the day, I hope it's just kind of one example of how engineering, how it's extremely difficult, but it is possible to kind of get your design from one point A to point B, but it takes a team, right? It's not just one person doing the design in the tunnel vision, right? It takes somebody coming in from the outside to see the design, right? And we've been there where we're designing something, and maybe to us we spent so much time on it that we don't know, or we don't see the mistake, right? For example, for me, when I was in college, I did a bridge project where it was a steel bridge. So we built a 20-foot steel bridge, and I competed 3 years, and 2 of the years we were DQ'd for something that was an oversight on our side. But you end up learning through it too. So that's just one example. But yeah, either way, we'll just keep moving forward. But that's just what we wanted to point out on this bridge. The reason we spent so much time on it is because it's an awesome bridge. We think all of the engineering that went into it was amazing. But yeah, there was just that little hiccup and at the end of the day, it's still gonna the team still did fine. But yeah, just wanted to express that.
And yeah, to kind of double up on what you've said there, Memo. It was a really great design and concept on really adding those different redundancies and really beefing up those members like that. Yeah, I think, one of the ways that that could have been worked around was if instead of sandwiching both of those cross members in between on those same faces, as if maybe one was just overlapped onto the outside face, and you would have been just fine.
Also decreasing the overlap. So right now the joints have 1 inch of overlap. Just reducing that to 0.75 of an inch would have solved the problem there too.
Sorry about these sides. So yeah.
There you go.
Okay. So yeah, Jared, we could swap back to your screen if you're ready.
Okay. All right, we're all good. Okay, and then we'll continue with the judging.
And the pattern continues throughout the bridge. Next is to check the bridge's sticks were not altered or modified. As we can see, the sticks were not altered or modified. Next is to check the bridge length. That's between a minimum 33 inches and a maximum of 43 inches.
38.5 inches.
All right. Next, we're checking the bridge height, which has a maximum of 12 inches. Bridge height is 4 1/4 inches. Now we're checking bridge width, maximum of 8 inches at the top. Bridge width is 4 inches. Now we have to check if the road is continuous, flat, and level. In the case of this bridge, most of the deck is continuous, flat, and level. As you can see in this middle section where we're going to do the loading, the sticks have a second layer which violates the level rule. So there will be a deduction for that violation.
So there was another minor deduction on here, as Memo just pointed out, where there would need to be something, flat and continuous. And it looks like they've got some stacked up here over the middle, which just gave it, not really a flat profile, as you look down the bridge. So that would have been one smaller violation.
Next, we're going to check that the bridge roadway minimum width is 4 inches.
Okay, they're doing the 4 inch width.
Next, we're going to check the bridge minimum height clearance. Roadway height clearance is 4 inches.
And now the roadway height clearance check.
We're at 4 inches. Now we're going to check the clearance of the roadway opening. It's 1.5 inches. Okay. Next is to check the bridge's weight.
Okay. Looks like all the other dimensions were good to go.
Bridge weight is 271 grams. That concludes the inspection of this bridge. Next up is bridge 203. First, we will check if the bridge is in compliance with the white all-purpose blue.
Okay, this is our third bridge.
We're almost to the fun part, everybody.
Yeah, we're getting there. Hey, bear with us.
Bridge is in compliance with the white.
This is Team Golden Gate.
Next is to check that the bridge is crafted from common wooden craft sticks. As we can see, the entire bridge is crafted from the same common wooden craft stick. Next, we're checking the bridge's 50% rule. In the case of this bridge, none of the sticks violate the 50% rule. Next is to check if none of the sticks were altered or modified, with the exception of the roadway. None of the sticks have been altered or modified. Next, we can check the bridge's length. Minimum of 33, maximum of 43.
40 inches.
Bridge length is 40 inches. Next is to check the bridge's height, maximum of 12 inches. Bridge height is 4¼ inches. Next is to check the bridge's width, maximum of 8 inches. Bridge width is 3¼ inches. Next is to check that the roadway is continuous, flat, and level. As we can see, continuous, flat, and level.
All right.
Next is to check the bridge's roadway minimum width clearance of 4 inches.
Looks like all the dimensions worked out. There's a level roadway,
so we're fine there.
And the inch and a half opening for the loading.
Height clearance. In this case, it's a deck bridge, so we don't have a height clearance, so we're fine.
There's no
loading
height clearance since the roadway deck is on top of the bridge, on top of the structure.
1.5 by 2, so that works. Next, we're going to check the bridge's weight.
All right.
Bridge weight is 171 grams. That concludes the inspection of this bridge.
Okay, great work, everybody. So we got the initial requirements out of the way.
Yeah, these 3 bridges are so efficient and light that we had to go get a gram scale because our pound scale was not registering it. Good job on the efficiency of the bridge.
So very efficient on your use of materials, everybody. Very, very efficient. That'll help out on that efficiency calc. Did anyone have any questions?
So far,
we'll keep an eye on the comment feed if anybody does. Let's go ahead and go to the actual exciting bridge breaking part of it. Okay, everybody see that video?
Yes.
All right, let's go for it. There's going to be a little bit of music. We're going to flash some of our awesome sponsors logos here. Just to start off, we had ASCE. They're a huge sponsor. They're from the YMF local level, the branch level, and the section level. And then we also had Mark Thomas and Company and Los Angeles Engineering Department as part of our sponsors this year. So huge shout out for supporting ourselves and supporting the students.
Jared, if you could unmute yourself, we'll get back that audio. So we have a force machine that we'll talk about at the end of the presentation, and Baby Yoda there was really supplemental to making the force work for this machine. So he's a cameo there that you'll see throughout.
Yeah, our force machine was pretty innovative this year. It's the first time using it. So, all right, we've got our Francisco Bravo Medical Magnet High School. This is our first bridge. So
we'll pause again. The little reader at the bottom, that's the force gauge telling us where we're at with the winch, right? So we use the winch at the bottom, a battery, and then the pulley system. So that winch or that force reader is going side by side with Jared and the loading device. So you'll see the numbers go up as the bridge gets loaded. The machine is smart enough to pick up the peak, right? The maximum force that was taken by the bridge before the bridge snapped, before the winch had zero force. So you'll be seeing the peak pound foot reading for each of the bridges.
Yeah, good point, Memo. And that'll also help you kind of identify where its critical break was. Once it peaks out, you'll pretty much see where the entire bridge failed. Okay, so we've got the prototypes. And here's a list of their members. We got Carly, Elmer, Saray, and Simran. Sorry if I butcher any names out there. Apologize ahead of time. And it's going to be quick.
Should be reading. Should be reading. Okay.
And there you go. 13.9 foot-pounds.
So for those familiar or not familiar, we'll take the weight that we grab, right? We got it in grams, we'll convert to pounds. And we're taking the efficiency and we're dividing, and we're going to get pretty much an efficiency calc. And that's essentially the entire calculation, right? It's just a quick division. And we use pretty much, it's a scaled weight where the bridge that held that was most efficient becomes the baseline, right? So that becomes 100% of the score, and then from there on, the bridge that is less efficient will be a fraction or a scale of that weighted distribution. So that's just a little bit of the math that we used.
Awesome. All right, and so now what we're about to watch is that entire braking process and loading process all over again, but we slowed it down. And we're just going to be able to see initially where those critical points are, where maybe something maybe broke or let loose, or kind of that critical point and critical moment on the bridge. So let's go ahead and take a look and see what we can discover. And right about, so as you can see here, what's happening is the roadway deck is separating away from its basically structural support, its girders. So all those trusses that they've designed and put together right now are kind of, they're still holding and they're still supporting. They're doing a great job. They're doing exactly what you designed them to do, Team Prototype. So great work. I guess it's the connection between the roadway and those trusses that's failed initially.
You know, and we're all human, right? So really, our bridges, they're gonna fail at the joints, right? At the connection points. You know, this competition is fair because we're using Elmer's glue, we're using white glue, so it's not a surprise that the bridge, or you know, in all our bridges are gonna snap at the joints because that's just how it is, you know. So yeah, like Jared said.
Yeah. I think one of the key things that really helps out a lot of these bridges in designing them is, like you said, Memo, it's a lot of those joints that are going to fail. So if you have maybe more redundancies where you have extra joints and extra members, that tends to usually really help out on the strength. But obviously, then you're just adding more weight, right? Which slightly hurts your efficiency calc. Okay, let's see what happens next from here. All right. Oh, and right there, you can see that the roadway has pretty much been exhausted on how flexible it can be. And now, since you have both of these truss systems no longer supported horizontally by this roadway, you're starting to see what looks like to be kind of a twisting motion. And there goes the members. All right. Any thoughts or comments from any of the team members? Sorry about that. Or any other thoughts, guys, on this bridge?
You covered it, man. Yeah, I mean, you know, we saw the snap like dead center at the top. and in the middle, you know, it's kind of it behaved the way we you know, physics tells us it's going to behave. You know, yeah.
Yeah, I feel like it would have this thing could have held a lot more if that separation didn't happen so early on.
Yeah, you know,
something that could have been done to mitigate that is, as you can see in the center, there's just that one vertical joint, which is essentially taking the whole load. The actual trusses themselves don't connect to that one vertical joint, so they don't assist as much as they could. So it was designed to be in a way where there were more than one member coming from that one point load. I feel like the trusses could have been engaged more efficiently, and the bridge would have ultimately held more weight.
That's a good point, Raul.
Thanks, Raul.
Okay. Okay. Great job, team prototype.
Alrighty. Moving on to the next one.
Another shout out, ASC, Orange County branch, whoop whoop. Mark Thomas, thanks for supporting. And City of Los Angeles, Engineering Public Works, thanks a lot. Okay, we've got another Francisco Bravo Medical Magnet High School team coming up. And Team Chevron. I thought this was an interesting name. And here we've got Christine, Kelly, and Michelle.
.5, 1, 1.1, 2.7, 3. Oh, we're getting that screen again. It's okay. It's okay. 7.7, 11.5, 15.1, 19.6, 26.7, 39, 45, 52. Still going, right? It's snapping, but it hasn't broken. 75, 90.
Oh, man.
90 pounds.
Great job. 90 foot-pounds. You got to love that crackling sound of when it's just starting to fail. That's great.
Yeah, no, I mean, this bridge was awesome. I mean, the stuff we were talking about earlier, it pays off here, right? You see the bridge took 90 pounds, and you know, it's all the engineering went into it. I think they did a great job, and yeah, good job.
I think Yoda was really putting the force on that one. He was just weighing it in.
Yeah, the craftsmanship, you guys, and the design was just it was great. It was genius, and the fact that the whole design, the X's, it allowed the distribution of loads throughout the bridge, allowing it to go up to 90 feet/pound. So great job, you guys, again.
Yeah, I think this bridge did come out as the heavier of all the bridges, if I'm correct. But I think it really paid off on the amount of load that it could handle and support. So probably well worth the added weight.
Yeah, I think it was like about 0.2 pounds more than the other bridges, but no, the three ladies that worked on this bridge, you guys did awesome. When we got this bridge, it was wrapped up, right? So it was kind of a surprise for us, like a little bit of an unboxing. So we were really surprised and really happy to see the product that was packaged. And good job to you guys too for packaging it and protecting it so well. Once we opened it, we realized why it was so protected, because it was an awesome bridge. Good job.
Okay, yeah. And now we're about to see this bridge fail all over again, but in slow-mo. So let's see if we can pinpoint any of the critical issues. Okay, slow-mo cam. And it actually takes a while before, oh, it's deflecting, deforming, and it's twisting. But it's all right. I mean, but look how uniform of a fail that was. Really, it was doing these slow twists, but it just kind of kept compensating and rocking itself back and forth until it just came straight down. And one thing I noticed about the fail is it didn't happen at a joint. It actually happened on the sticks. So that's pretty unique.
Yeah, you can just tell by the way this bridge ultimately broke at the end that the weight was distributed across the whole span of the bridge, which was an intention that the team had. So good job on that.
See, one thing that was rare here is we rarely see bridges deflect this much before they snap, right? If you back it up just a bit there before it snapped, you'll see how much deflection we got out of it before it actually snapped, before it gave, right? Because usually like I was talking about earlier, the connection is going to give before the deflection gives, right? But here we were able to get, even if you keep going, I think there was more. So,
yeah, like right there.
That deflection right there, that just proves how awesome this bridge was, right? Because bridges in real life, they're not meant to be totally rigid. They're meant to have some ability to flex with either the heat or the load. If bridges were totally rigid, we'd have more failures, right? So this bridge kind of proves of what you could do, right? The flexibility that bridges are allowed. Of course, we knew we were loading it to the max load, right? But if we would have put 50 pounds, if somebody would have put a couple books on here, maybe you all tested it already. I think we read about that. This bridge would have performed just like it should have, right? We knew that our bridges were being loaded to the point of failure. But yeah, good job.
Yeah, great work. Let's watch this thing break one more time. Nice. There it is. You can see again how the winch is remotely being pulled down. And I'm over here with an actual button that essentially it's a remote and a button that'll let me make it go up and down. And then there's a controller box that you can't see back here, but it allows how much energy is going down to this winch. So I have it on the lowest setting. So that's why you kind of get that slow creaking movement. And it's consistent for all the bridges so that they're all being pulled at the same rate.
We still have your supervising.
All right, let's do it again. Another Francisco Bravo, Medical Magnet High School. Woo! Let's go Team Golden Gate. It's a great looking bridge.
It's a clean bridge. I like it.
Yeah. We've got Nadia, Isaac, Brenda, and Caitlin.
Point 1, 0.2, 0.3, 0.5, 0.7, 1 pound, 2.2, 4.3, 6.7. 6.7 was a peak. 6.7. Yep.
All right, 6.7.
All right. That's a wrap, dude.
So
what are you guys' thoughts?
So yeah, the main thing that kind of stuck out to me with this one is we had a deck bridge where I think the thing that hurt this bridge is the amount of surface area that was between the rails and the deck. That's we'll see in the close-ups and then some pictures later. The sticks themselves started to disconnect kind of early on, and that's kind of the big thing. So obviously more surface area gives you stronger strength. But of course, you know, we can't. That's what the 50% rule is, right? We can't max out our surface area because then you end up with bridges that just take too much. So that was kind of my main thought with this one. I liked it because it was simple and clean. It was I think it was our lightest bridge. So yeah.
Another thing on this one, which will probably be more apparent once we do the slow-mo, but this bridge failed because of the lateral aspect of it. It wasn't reinforced. So just looking down, the legs didn't have a connection on the bottom holding them together. So as you can see, one of them kind of bent inward. And as soon as that started to happen, that's when the whole thing snapped. So just more bracing in between the two supports to keep them more rigid would have been helpful.
That horizontal reinforcement as you look down the bridge, right?
Yeah.
One thing I thought that was really cool about this bridge is that it had like a very aesthetic, you know, look to it. I'll play forward a little bit so that we can get back to looking at the bridge. But right here, I mean, it's just a very aesthetically pleasing looking bridge. Very symmetrical. It's got that really neat deck on top. What bridge has that? Is that like not the Bay Bridge, but it's the other Bay Bridge? Where it's got the double deck, but that deck's completely on top. It's really pretty.
Yeah, it's clean.
It's very clean looking. All right, let's watch this bridge break in slow-mo. Okay.
So right there, you see how the leg twisted in, and as soon as that happened, the whole bridge just collapsed at that point.
Right. Because I think this entire truss system would have to be so perfectly vertical for it to never really twist in, and the weight distribution would have to be like perfect in an ideal situation for it to not want to turn in or turn out.
Yeah.
But, so it's just really lacking just that other support going across this bottom part of the girders as part of this truss system. And then once that happens, then you just see all utter destruction and chaos.
Yeah, at that point, the truss system isn't being applied.
Right. Then it's just whatever strength you have in the connections going across the bridge that's basically holding the entire structure. So great work. I mean, you could tell a lot of design and thought, and I like how everything was unique. Not one bridge was alike. So just a lot of creativity went into here, and it's neat to see all the different types of systems being tried here. And you can see, you know, they're really representative of a lot of things in real life. So great work. Team Golden Gate, good job.
Here we just wanted to feature that packaging because it was
yeah, that packaging in the back, that was our Christmas gift.
Yeah, it was like in an Amazon package delivered.
Thank you guys for the waters and the soda. It was much appreciated.
It's great. And so another huge thank you to ASE, our branch, our section, our YMF, and all the volunteers that were out there helping put this together, and especially our sponsors, the City of Los Angeles, the Department of Engineering, Mark Thomas and Company, and all of you out there that submitted those bridges, and the students, and especially the advisors that have been doing this for so long and continue supporting your students and supporting STEM and education. So great work.
Yeah, you know, and then especially for the students, right? Thank you for letting us break your bridges. We hope seeing it break doesn't break your heart. We hope that you know, if you're not graduating yet, that you come back next year, and you know, while you're in high school, and you know, even if you're graduating, you pass down the mentorship and teach the younger students. Because yeah, that's essentially what we do it for, right? Hopefully, students learn from it, and you know, next generations come in and do the same thing. Yeah.
And there's a huge incentive. I mean, you're getting a wonderful educational benefit, but also you're getting a little bit of scholarship money to help you with your future endeavors. So, you know, keep studying hard and keep up the good work. If anyone has any questions, we're completely open for questions from anyone that's watching.
And we took some day of pictures. We kind of flipped through just so you guys see the nice shots that we have.
You want me to share your screen, Noah?
Yeah, give me 1 second.
Yeah, and I know that you all had a lot of fun putting these bridges together, but you probably didn't have as much fun as we had getting to break them. So. Definitely a cool thing. And we're happy that you're able to all virtually watch it happen. I hope this was a good experience for all of you. If you have any comments on that too, I think next year, you know, we'll be looking to do maybe something similar or change it up a bit. This was a really good demo for this year to see how it worked out. And if you have any feedback, we're completely open to it.
Yeah, even if it's not now, you all have our email. Like Jared said, this year might be a prelude to this coming year. You know, it all depends on the pandemic and what we could do with venues. But ultimately, if we can't book a venue for a large amount of audience, you know, it might just default to virtual again. And, you know, we understand that, you know, it's really difficult on the school end, right? Because the advisors, you know, that are our main advocates out there at schools, you know, aren't necessarily with their students every day, right? Because students are remote as well, you know, so it's a challenge, you know, just like these past 3 months have been a challenge for every other aspect. PSBC is just another one of those aspects. But again, you know, our 3 teams that stuck it out this year, you know, you're being rewarded for your efforts in the placement for first, second, and third, and we'll share those placements just in a bit. But yeah, you know, we really appreciate the effort, and yeah, if this is the same approach for next year, hopefully it's not a deterrent to our students. We hope to keep the engagement, to keep other schools involved too. So yeah, Jared, we can flip to mine and we'll just share a couple pics and talk about day of stuff.
All right.
Cool. So yeah, these are just some nice shots on the loading machine. You know, last year we used just actual sand, and it was great. But what happened was it kind of it's a little bit of a lag. You're resetting for the next bridge, right? So luckily for this one, we were able to oh, are we still there? Yeah, we're still there. To use this new mechanism. We built this in 2019, and just, you know, right at the beginning of PSBC, we wanted to do something a little different. Yeah, so I'll share a couple pics.
Awesome. So yeah, that's our winch system, and there's a sensor right in between that it's like a force sensor that tells you exactly, you know, to a very precise measurement how much force is being applied to your bridges. We thought it was kind of a safe way to do it, where you can separate yourself from the machine. And instead of having, like Memo said, you know, pick up, you know, some odd, you know, 50 pounds at a time, loads of sand, and stand there steadily, you know, pouring it into a bucket. I experienced that years before, and it's one way to do it, and it definitely works. But this one, we kind of got creative with it and try to create a system that can be used for years to come, and is going to be safe and a little bit more efficient. It's all about efficiency, right?
I see some comments. Darlin, thanks for tuning in. Happy to have you here. And then Michael, yeah, we're happy to hear that, you know, whatever type of format, we'll have you participating. So yeah, that's awesome. We can see there's Victor holding the bridge. You know, this bridge was awesome, and we might put it up on a shelf somewhere just because it was so nice.
Yeah, and I don't know if but you're seeing all these awesome shirts in the screens. Thanks again for our sponsors helping to make these shirts happen. But I mean, these are some really good looking shirts. Hey, Memo, who was it that helped design these shirts?
It was FH Printworks in Alhambra. So yeah, Blanca over there helped us out. Same contact from last year's shirts. So yeah, a big thank you to her. Yeah, she did a really rush order for us, and you know her schedule changed too with the pandemic, but she was able to get us our shirts. And like we said, we have all of our shirts for all of our participants, our advisors, our volunteers, the people that supported us the whole year through. We have shirts for everybody, so we did account for all of that.
What about the logo? Who put that logo together?
Judy. Oh, that was Judy Beck.
Yeah.
Involved in YMF. She helped out with designing this great OC logo that you see here.
Great job. Thanks again. I want to make sure we recognize all the awesome volunteers that help make this happen, and everyone's continued support. So if there's nothing else, guys, I think we can wrap up this year's PSBC.
We need to also thank Tulip. That was Tulip back there, supervising the whole day. That we did everything safely. Let's see.
She's so sweet. It's our Pekingese princess. Oh yeah, and if you want any of these photos, just reach out to us, and we can give you a ton of awesome broken bridge photos. Well, maybe just create a drive and
before they broke you.
Yeah, tons of photos for everyone to flip through. We'll have to give these to like our media people to spam out there. That awesome. And I hope everyone liked the added touch of Baby Yoda. There's a lot of force happening, so we figured we might as well let Yoda show you where the force is coming from.
Yeah, that's the last picture. Then lastly, so our placement. So zoomed in here. So coincidentally, our team naming is the way we took gold. So team 1 got first. Team 2 would place second, and Team 3 placed third. So yeah, good job to our teams. This year, you know, of course, we talked about it. It was a different format, so we had our 3 teams. You guys stuck it out. You guys all getting rewarded. We'll talk to Michael and kind of work out how we're getting those checks to you here in the next couple days, and your T-shirts as well. So yeah, that's yet to come. But yeah, you know, we had a lot of fun, and it was a different experience, right? Because of everything, but it was real rewarding, and you know, we had a blast doing it the whole way through.
Yeah. So team 1, that's our the prototypes, right?
Right.
Great job, prototypes. Okay. Yep. And then yeah, team 2, Chevron. Chevron, right?
Chevron.
Okay. Yep. Great job, Chevron. And then team 3 is the Team Golden Gate. So great job, and shout out to all the teams out there.
Yep.
Good work.
Yep, and I think that sums it up. So let's see if there's any more questions that came in at the very end. Clarissa, Marianne, thanks everybody for tuning in. Yeah, so hopefully, I think, you know, we're not the most tech savvy, but I think we're going to be able to upload this to our YouTube page. So if you want to share with anybody, hopefully it's still there. You know, this was a live version. We did everything pre-recorded and then talked live over it. So, you know, hopefully it's still there to share if anybody does want to share. If you want to show your parents or show any guardians or anything, so everything will be there. And if you have questions, you know, you have our email. You can reach out. But yeah, thank you, students, and we hope to see you next year if you're not graduating yet. If you graduated or are close to graduating, congratulations. Good luck on your endeavors in the future. If anybody's going forward with engineering, you know, or any major in, you know, that's awesome. Congratulations, and good luck to the seniors in college, and good luck to the remaining high school students in the future high school years to come.
Awesome. Yeah, and last plug for our K through 12. We do a lot of events at high schools. I know with the pandemic and COVID-19 going on, that it's hard and it's a challenge for people to come in and do presentations and talks and educational events. But if we want to try to set up anything with us in the future, we're happy to do something virtual where we talk about most any engineering subject and be able to present for you and your class and do some sort of activity. So just reach out to us. We're here to help.
Yep. All righty. Thanks, everybody.
Okay, bye, everybody.
You guys.